The purpose of this video is to demonstrate the module attachment to MBL's DSA pre-check structural design. The need for the video and motivation is to show the best-in-class attachment of modules to DSA pre-approved canopy structures. In this video, you will see a standard purlin and design details that match the pre-check as approved by DSA. As such, these purlins are suspended on 27-foot centers with modules attached to them in accordance with the DSA pre-check design. What you are seeing here is the standard blocking design for the modular and purlin attachment. In addition, you are seeing the top-down clip design that is unique to our module attachment. The module clip seen in this image is a jig that assures square, accurate, and properly positioned modules on the mounting purlin. The jig is set in place on the purlin and positioned for module attachment. Certain characteristics of this clip that make it unique is that each and every clip has a locator tab that ensures the module mounting hole is set over this tab. In addition, the rib of the jig assures consistent spacing between modules and the complete and proper vertical installation of the mounting screw or screws. Once installed, the locating tab penetrates through the module manufacturer's mounting hole as seen in this image. The solar washer has positioning ears that sit between the module to ensure that it cannot be rotated out of alignment with a fully seated clip that is square in to the module frame and to the mounting purlin. The top-down attachment clip is not at all a traditional clamp attachment. Although it clamps the frame of the module, the locating tabs also position the module and wedge it in place to assure that it cannot be displaced during deflection. We will now show and demonstrate the module's capacity by inverting the portrait mounted module. In preparation for loading modules up with weight, this unit will be turned upside down. Understanding that one of the concerns is the flexibility and movement of the purlin itself, this video will also demonstrate that the MBL module clip attachment has the capacity to overcome extreme movement of the purlins without jeopardizing the security of the module to the member. Okay, the module's unit is upside down, and we will prepare to load weight onto the module with all of the deflection on moving the unit around. Even with all the moving around, the twisting in of the module, there was no displacement of the clip or the module from the mounting holes or of the fastener itself. Now we will prepare for the load test. For this test, we will be loading the center module, and we will be placing the weight on both ends and in the middle. Canadian Solar 72 cell module, approximate dimensions 74 inches by 39.8. For our test, we will be using 50-pound sacks of grout. We confirmed through the material data sheet that each one of these bags weighs 50 pounds. For the purpose of the test, we added these flat pieces of steel so that the weight of the bags will not crush the glass, and the transfer of the weight will be directly to the frame of the module. We have 100 pounds on the first module. That's 200 pounds. And we have taken particular caution in assuring that the weight is not being supported by either of the adjacent modules. The single module clipped with the MBL pre-check design clip is now supporting 400 pounds. 600 pounds. We now have 800 pounds, which is a safety factor of 2. Purlins are on 27-foot centers and are beginning to show some deflection. With 800 pounds supported by the module, frame, and clip alone, we see some deflection, but the fastener, washer, and locating tab are still in place and functioning as designed. Locating tab preventing the frame of the module in any way from being affected by the deflection of the purlin. Current weight on one single module supported by MBL mounting clip is 1,000 pounds. 1,200 pounds on one module. 1,300 pounds resting on one single module secured with one fastener. We have 1,800 pounds suspended on the single module. 1,900 pounds. We are seeing noticeable deflection in the frame of the solar module itself. We are seeing a solar panel clip. So for the purposes of this test, we are more than 3 times the specified wind capacity and have the module attachment to the purlin still performing as designed, despite deflection in the Z-purlin and bowing of the aluminum frame of the module under the weight of the grout.